So today we're going to be discussing positive aircraft control. Now this is one of the special emphasis areas found in the PTS, and if I were to look back to my student pilot days, I feel like this would be like an obvious point. Like I wouldn't understand why they put it in there. Obviously, you want to have control over the airplane. But as I've continued my flight training, and now I'm to the point where I'm about to start teaching students, I realize how important of a topic this is to teach. So positive aircraft control can basically be summed up in one sentence: just fly the airplane. I know that seems obvious, but things come up, distractions come up in the cockpit, and you never want to stop flying the airplane. I know one very popular saying among in the aircraft community is aviate, navigate, and communicate. Aviate is first on that list for a reason. Above anything else, just keep flying the plane. Uh, if you're in an emergency situation, if you do your navigation and communication perfectly, but you forget to fly the plane, it doesn't matter. You're gonna crash the aircraft. So that is why it's crucially important to fly the plane. Uh, for example, if you're taking off and you have an engine failure and you're not even at pattern altitude yet, you shouldn't focus on troubleshooting the problem. It might be an easy problem to fix, but that should not be your main concern. First of all, again, keep flying the plane, pitch for best glide, and then navigate, get yourself to a suitable landing place, and communicate. You might just want to quick call up a ATC, let them know what's going on. You might even have time to communicate, and that's all right as long as you're flying the plane. So, another main reason why you'd want positive aircraft control is distractions will come up in the cockpit. I know my student pilot days, checklists were a bit of a problem for me. That was a big distraction. I'd look down at my checklist and I'd look back up at the airplane and I'd be way off my altitude, way off my heading, whatever. And then as I got into instrument flying, the approach briefs were a problem. So I'd had to learn to multitask, for lack of a better word there. And then also, as you're flying with passengers, they may be totally clueless about what's going on in the plane. So you really want to, a passenger briefing is extremely important, just so, especially in critical phases of flight, they're not messing you up in any way. And also make sure to do a still cockpit, just so, for example, on takeoff and landing, they're not talking to you about stuff that has nothing to do with anything. So that's the points I want to bring out on positive aircraft control. The other thing I want to touch today on a different topic is basic aerodynamics. So I've drawn here an airplane. If you can't tell by my poor drawing, this is the nose of the airplane, the tail, and obviously the top and the bottom. So there are four main forces that act on an airplane in flight. The first one goes straight down, and that would be gravity. Now, I bring this one up first just because it's something that we all deal with on a daily basis. Everyone knows what it is. Just a heavy piece of metal in the air wants to come down. It doesn't want to be up there. And then opposing gravity, which goes up, we have lift. Now, lift is what's generated by the wings, and that's what keeps us in the air. And if these two forces are balanced, then we will have level flight. So we won't be climbing or descending. And then, in the forward direction, we have thrust. Now, this is generated by the engine and the propeller, or a jet engine if you're flying one of those planes, which you probably won't be for a while. So this is what pulls you through the air, and then opposing that, going backwards, we have drag. So that's the result of the airplane pushing air out of the way, and that air is pushing the airplane back. So if these two forces are balanced, then we will have unaccelerated flight. So you're not accelerating and you're not decelerating. So when all four of these forces are in balance, then you will have level unaccelerated flight. So one thing I want to bring out is that one of the main sources of drag is a byproduct of lift. That's induced drag, especially at slower speeds. So think of it as when you stick your hand out a car window. If you have it level, the air's just moving around it. But if you tilt the front of your hand up, your hand will want to move up and back. So that's how kind of the relationship between lift and drag is. So now we'll take a minute. Oh, come on. And we're going to discuss how lift is generated, if this will erase. That's good enough. So for here, I'll draw a cross section of a wing, kind of round up in the beginning, and then it trails off, and then the bottom is relatively flat. So here, this is the cross section of a wing, and your chord line, which is the imaginary line that goes from the front of the leading edge to the very back of the wing, the trailing edge. So what happens is that when air moves over the wing, it comes from over here, it will want to go up and conform over the shape of the wing and trail off like that. And same for the bottom. So because the air up here has to travel a farther distance, because of Bernoulli's principle, it will speed up and the pressure here will drop. So you'll have a low pressure system up here. And then because the air here is relatively unobstructed, it's moving a lot slower than the air up here. Again, because of Bernoulli, the air pressure up here will increase. So you'll have a high pressure up here and a low pressure up here. So just think of the air down here wants to go, because there's a lot more air up here than up here. So the air will want to travel to the low pressure system, but the wing gets in the way, and that's what generates lift there. Alright, so that's basically how lift is generated. And then let me also add, when you add flaps, that's considered to be a high lift device. It increases your lift and it also increases your drag. So it comes down somewhat like that. Then the airflow will look more like this. And then your new chord line will be something like that, more or less. So basically what that does, that allows you to have a steeper approach to landing, but with a slower airspeed, because this will increase that angle of attack, that chord line of your wing, without increasing your pitch up attitude. Alright, so I think we got that. This eraser does not want to work. Alright, and the last thing I want to talk about is how the airplane maneuvers. So to understand that, you need to know the airplane's center of gravity. So let's see. Oh, this is going to be a bad drawing of an airplane, but that's okay. And I got that. Alright, so your center of gravity is basically where the airplane wants to rotate about in 3 dimensions. So it would be up, down, and then, so pitch up, down, be roll left, right, and yaw left, right. So that should be somewhere approximately right there. So basically that's the point that your airplane rotates about whenever you apply any control surfaces. So for example here, the ailerons, which would be up here on the wing. Just imagine this wasn't a biplane. So if you want to say turn to the left, for example, your left aileron, that will go down. That will go up, creating less lift. So it's like you didn't have flaps in, for example. And the upwing aileron, which would be on your right side, will go down. That will create that rolling motion. Same goes for the elevator in the back. If you want to pitch up, the elevator comes up, and so that creates a force down motion, and then you'll rotate around your center of gravity. Same to go with the rolling of the ailerons. And then when the elevator goes down, then you get that pitch down, again about the center of gravity. And lastly, you have the yaw, which is from the rudder. And so just think about when the rudder goes to the left, for example, then the wind comes and will hit that and will push the tail to the right, and then the nose will go to the left because you're rotating again around your center of gravity. So that's basically all I have for you on positive aircraft control and aerodynamics. I hope you learned something.